Okay, what we're going to do today is take a look at some hints that I've organized for Chapter 2, Solving Equations. Now, there's a series of steps that I've put over here, and I'll highlight them, for solving an equation. And 1, 2, 3, and 4 actually are going to come later as we go down through the various examples. So let's just go through them. Step 1, as we'll see in equation number 5 here, example 5, has a fraction. So the first thing you want to do is get rid of the fraction. In example 6, there's a decimal fraction. So the first thing we'll do is get rid of that fraction. Then we're going to remove a grouping symbol, whichever they happen to be. Most often they are parentheses. And we see that in example 4 and example 6. Then we want to combine like terms. This is a topic we treated in chapter 1. Then we're going to do some transposition. So we get all the variables, let's say, on the left and all the numbers on the right. Then our last step, we're going to divide by the number that's with the x. This is called the numerical coefficient of x. And that's a form of the multiplication property. Division and multiplication work hand in hand. So those were the steps. We're going to start off real easy with a simple equation. Now what I've done here, and let me make it nicely here. Okay, there's the equation. And I've put that little arrow by it to indicate the actual equation we're going to deal with. This is probably the most simple type, where you have a letter, a number, equals a number. And what we're saying is what is on the left is equal to what is on the right. So we want to isolate the letter x so that it's all by itself. Well, then we look at the positive 3. Well, what do we need to add to a positive 3 to make it a 0? And that was in chapter 1 also. We said it was the additive inverse. It's what we add to a number to make it 0. And it's usually the number with the opposite sign. So we see we have a positive 3, so we're going to add a negative 3. That makes that a 0, and on the left, we're just left with an x. And on the right, whatever we do to the left, we must do on the right side of the equation to keep the balance. We subtract 3 there as well, and we get x equals 12. So a very easy one. Now in example 2, the basic equation is this. A negative 3x equals 15. So there's just the term with the variable on the left. So we go now to rule number 5, divide by the number that's with the x. So the number, that's the numerical coefficient, is a negative 3. We divide by a negative 3. The other side by a negative 3. And here we have to be careful of our signs. Here it becomes a positive 1, 1x. We don't write the 1. And then that is equal to a negative 5 when we do the division. Now for example 3, we're getting a little bit more complicated because now we have a variable, a number, a variable. This is sort of what we want to have after step 3 over here. But let's get back to this one. Oh, let me do that again here. So we also want to note that we're going to try to keep our variables positive. That way we don't have to worry about dividing by a negative. So we have a 5y and a 3y. So I will subtract a 3y from this side, and that'll make that a 0. We're left with a 10. And I'm going to subtract a 3y from this side. That leaves me with 2y. And I have this next item right here. So again, I want to isolate the variable. So I'm going to add the additive inverse of a -4, which is a +4, to both sides. This gives me a 14 on this side. This is 0. I now have 2y equals 14. And then I'm going to divide by the numerical coefficient of y, which is 2. And I get y equals 7. Now, an interesting thing to note, that as we do these steps, I'm sort of keeping the equal signs underneath each other and doing something sequential, so eventually I end up with a solution. In the case of example 1, x equals 12. Example 2, x equals -5. And then example 3, y equals 7. And these steps that we go through to solve the equation are called solving the equation. Generally, when we would have a paper test, I would demand that the students showed the work in a sequential form of how they arrived at the solution. All right, let's go on to example 4. Now here we see we have a case where there is a parenthesis. So the second rule, remove grouping symbols, that is a parenthesis, and we're going to use the distributive process. 3 times 2x gives me 6x. 3 times a +4 gives me a +12. And now I have the case of a variable, a number, a variable, a number. And again, I want my variables to be positive. I have a 6x and a 9x. So I'm going to do the additive inverse of 6x, which is a -6x, from both sides. This leaves me with a 3x minus 3 on the right equals 12. I'm now going to add 3 to the -3, and that to both sides. I now get on the left 15, then equals 3x. My numerical coefficient of x is 3. Divide both sides by 3. I get x equals 5. And once again, what I have here is the steps shown here are called solving an equation. This is sort of key. And as you develop this pattern, that'll be very useful for you. All right, going on to example 5. Let me highlight it here for you. We note that this example has fractions. And rule number 1, that I'm sort of hiding a little bit, let me go up there again, says clear equation of fractions by multiplying each term by the least common denominator. Well, here I have a 5 and I have a 3. So what would the least common denominator be of a 5 and a 3? And the answer is 15. So I have 3 terms. I'm going to multiply each term by 15. And in this case, I wrote the equation again so you can see how we do it. We put a 15 by each term. And now we're going to multiply 15 by this first fraction. But before I do it, I'm going to cancel out the 5 into the 15 and get a 3. And then I do the 3 goes in the 3 once, 3 goes in the 15 5 times. So what I have in my denominators now are just ones because I have changed this equation. It's not the same anymore, but it's equivalent. And because there's no fractions, it's much easier to work it. So now I'm going to distribute 3 times 2x gives me 6x. And notice our negative sign here. Negative 5 times x is negative 5x. And then 5 times 15 is 75. Well, I combine like terms. X equals 75. Now, in doing example 6, this sort of involves all of the steps above because we're going to try to get rid of these decimals. And what you do is this is one term. This is one term. So I'm going to multiply these terms by 10. And the short way of multiplying by 10 is you just move the decimal place over one place. So that makes this 3.4 a 34 and a negative 0.2 a negative 2. So in this form down here, you have a much easier equation. I guess I tended to drift up there a little bit, so they're not quite horizontal. But then I go 34 times 2x is 68x. 34 times 5 is 170. And then a negative 2 times 2x is a negative 4x. And a negative 2 times 5 is a negative 10. So now I have a variable, a number, a variable, a number. I want to get all my variables on one side. So it's obvious I will add 4x here, add 4x there. That gives me a 72. I will subtract 170. Subtract 170. I get a negative 180. And now I'm going to divide by the numerical coefficient of my variable, which is 72. And notice it's a positive 180 divided by 72, which I have here. And if you put that as an answer, on a paper test, I would give you just 1 point off because look at, you did all of this, but that's not the answer they're looking for because they want you to simplify this. Now I can actually take out a 9 out of the top part and I get a 20. And I notice that 8 times 9 was 72. So I ended up with an 8, taking a 9 out of each one. Now what I'm going to do is take a 4 out of the 8 and I get a 2. And I take a 4 out of my 20 and get a 5. And remember, that was a negative. So there is your final answer. Okay? Came out like this, but then you had to reduce it. So basically, I'm taking a 36 out of each one of these, and that would be kind of hard to figure out initially. But 5 times 36 is 180. And 2 times 36 is 72. So that's where we are. And I tried to show you this little intermediate step of how I reduced it to get to my answer. Okay, again, you're going to have an opportunity to do examples on Practice and Quiz Me. You also have those little additional examples that I've worked up for you. And we also have those on integrity. So good luck on this section. And any questions, bring them to your tutors.